deviation. This lesson is from Mrs. Cucci's College Now Calculus class. Today we're going to be talking a little bit more about solving systems of equations using matrices. So this is where we left off from the last video. Today we're going to be talking about row echelon form. So basically, row echelon form is, we have some criteria that it has to meet. First one is if a row does not consist entirely of zeros, then the first non-zero element in the row is a 1. Okay, so that has to happen in order for it to be row echelon. Criteria 2, for any two successive non-zero rows, the leading one is in the lower row is farther to the right than the leading one in the higher row. Number 3, all of the rows consisting entirely of 0 are at the bottom of the matrix. And the fourth property is also satisfied if the matrix is said to be in reduced row echelon form, and we'll talk more about reduced row echelon form after. And this happens when each column that contains a leading 1 has zeros everywhere else. Okay? So, we're going to look at a couple that are in reduced row, or in row echelon form, and then we'll talk about what one looks like in reduced row echelon. So just an example of something that's in row echelon form. For example, it would be something like this. This is row echelon form. And again, when we looked at our notes yesterday, we said that this was important, right? We had those ones diagonal, and then we had these zeros here. Okay, so that's row echelon. Reduced row echelon is a little bit different. Reduced row echelon is all zeros and ones. Okay, so 0, 0, say negative 2.4. 0, 1, 0, 0.8. 0, 0, 1, 5.6. So everything in this portion of the matrix is zeros and ones, and then we have our constants on this side. Okay. Basically, what would this would give me would be x equals negative 2.4, y equals 0.8. and z equals 5.6. So it's reduced row echelon. Okay? Alright, so what we're going to do next is we're actually going to take the matrix that we found in example 1, and we're going to use Gauss-Jordan elimination to solve the system of the equation. Okay, so the matrix that we received in number 1 is row echelon 1. And look, I'll just put that back up so you can remember what it is here, so we won't need it. This is the matrix. So what we're going to do is we are going to take it and put it into reduced row echelon. So basically we want to take all of these values here, right, and turn them into zeros. That's the goal. So it's in reduced row echelon. The same kind of, we're going to do it the same way that we did when we were working with elimination. Just your goal is to get those things to cancel. Okay, so the first thing we're going to do is we are going to attempt to get rid of this negative 10 there. Okay? So, which row could I use? Could I multiply something by? Oops, I don't know why that happens. To get rid of that negative 10. So, my suggestion here is let's multiply row 3 by a positive 10. Okay? If we do that, my new matrix becomes 1, negative 2, negative 10. 6, 0, 1, 8, 3, 0, 0, 10, negative 5. Okay? So now you notice we've got this negative 10 and we have a positive 10. So my next goal will be to take row 1 and add it to row 3. And remember, the row that we messed with is the row that goes back to its original. So this is going to go back to 0, 0, 1, negative 1 half. The second one stays because we never touched them in the first place. And when I add these two together, I get 1, negative 2, 0, negative 11. So now I've got another 1 there. So I still have to get rid of that negative 2, and I have to get rid of the 8, so we need to do some more work here. So now let's focus on getting rid of that 8. Okay, we're going to focus on getting rid of this 8 now. Okay, so let's use row 3 again. And we're going to take and we're going to multiply row 3 by a negative 8. Okay. So what that's going to do, again, my first row doesn't change, so I'm just going to write that back in there. My second row doesn't change. My third row becomes 0, 0, negative 8, 4. So now what I'm able to do is I'm able to do row 2 plus row 3, which when I put these together, again, first row doesn't change, let's put it back. I messed with row 3, so that's going to go back to its original. And when I add these two together now, we get 0, 1, 0, 7. So now the last thing that we have to get rid of here is going to be this negative 2. So I can use row 2 and multiply row 2 by 2, right? And multiply row 2 by 2, that's going to give me 1, negative 2, 0, negative 11, 0, 2, 0, 7, 0, 0, 1, negative 1 half. Now that I have this, I can do row 1 plus row 2. And that's going to get me 1, 0, 0. Hold on. This is what's important. Sorry about this. Right. That's going to give me a 3. This one reverts back, right, because it's the one we messed with originally, so it reverts back, 0, 1, 0, 7. And then this one we never changed, 0, 0, 1, negative 1 half. So now what I have here is reduced row echelon form. So I can very easily pull my answers. X is going to be 3, Y is going to be 7, Z is going to be negative 1 half. So 3, 7, negative 1 half is my solution. Okay, so we're going to try another example here. I'll give you a new matrix. 3, negative 4, negative 1, 6, 2, negative 1, 1, negative 1, 4, negative 7, negative 3. And we need to go ahead and put this in the right form. Remember, we want that smallest value up top, and then this value 2 we want in the first row, and then rows 2 and 3 need to be multiples of that. So we're going to have to multiply through by a factor. So let's do a little adjusting. 2, negative 1, 1, negative 1. So this next one, since it needs to be a factor of 2 or multiple of 2, 6 would be the easiest way to go. So we have to multiply this whole thing through by 2, which is going to give me 6, negative 8, negative 2, 12. And then this also has to be a multiple of 2, but we want it to go, since it already is, we can just leave it. Actually, let's make it so that it's larger. So let's make this, since we want it, again, a multiple of 2. sorry about that, guys. I'm going to leave it in this order as it is here. Okay? I'm just going to change the values by multiplying. I'm going to leave that 3 in the top. Since I want this to be multiples, let's multiply this by 3 and this by 3 as well. Okay? There's more than one way to do this, but I want to stick with what I have on my paper just so I don't lose track in the middle and then be confused. So remember, smallest on top, and then it's multiples of 3, so 6 and 12 per. Okay, so we want to get this into that row echelon form. So we need to start getting rid of things, right? So what I can do to start is I can take that first row and multiply it through by -2. If I do that, it's going to allow me to get rid of this 6 right here, right? It's going to give me -6, 8, 2, -12, 6, -3, 3, -3. And then this will be changed from rewriting. Okay. Then I can do row 1 plus row 2, and that's going to get rid of that 6 with me, right? Remember, we messed with row 1, so row 1's going to revert back. 3, -4, -1, 6. We're adding here now. Which is going to give me 0, 5, 5, -15. And then row 3 we didn't touch. Okay. So again, we want this row echelon. So we want this and this to be zeros. Okay, so that's what we're working towards. So let's go about getting rid of the 12. Again, I can use row 1. Let's multiply through by -4. Okay, multiply through by -4. And when I do that, I get -12, 16, 4, 20, -24, 0, 5, 5, -15. 12, -21, -9, 39. So here we are, right? We want to put those together, row 1 plus row 3. That's with row 1, so row 1's going to revert back. -4, -1, 6. We're adding here now. Well, actually, this first one now. 0, 5, 5, -15. Now add. Right here, 0, okay, negative, -5, -5, 15. I do not know why it does that. I'm going to rewrite this. Nobody. Here's where we are right now. 3, -4, -1, 6. 0, 5, 5, -15. 0, -5, -5, 15. Alright, so still working to get rid of this. We want it to be 0. So it looks like we can go straight to adding here. Row 2 plus row 3, right? If I add these two rows together, first row stays. I don't need to do anything with that as of right now. Second row, we get 0. When I add these together, 0, 0, 0. So we kind of have an issue, right? So what we're going to do is we're going to stop. What I have here are two equations. I've got 3x minus 4y minus c equals 6. And I have 5y plus 5z equals negative 15. Then I have negative 5y minus 5z equals positive 2, which is the same thing, okay? So I have two equations. So we're going to get infinite number of solutions here again. So our solutions are not going to be specific, our solution set is going to be specific numbers, it's going to be expressions. Okay, so we have to go and we need to think about how we need to write this. So we know that from past experience we're going to have z as z. So all of our solutions and expressions are going to be written in terms of z. So we're going to take this as 5z equals negative 5y minus 15. Or z equals, oops, I'm solving for y. 5y equals negative 5z minus 15. Y equals negative z minus 3. So now I've got my y value. Okay. So what I need is my x. I know what y is. I know z is z. We need to find x. So 3x minus 4 times y, which we said was negative z minus 3, minus z equals 6. 3x plus 4z plus 12 minus z equals 6. And again, we're solving for x, so 3x plus 3z equals negative 6. 3x equals negative 3z minus 6, or x equals negative z minus 2. So this becomes negative z minus 2. And these three expressions will give us every single value for x, y, and z that are possible for solutions. All right, so that is all for today. Come prepared with questions, and I will see you tomorrow.